our way. But that's about it. And for any students just coming in now, if you've not taken the quiz from last week, make sure you take it before Friday. I will send it over to Mr. King to do the warm-up. We are on page 23 of our note packet.
All right, so today we're going to be looking at mathematical models and what that looks like in algebra. So we're going to look at examples 3 and 4. Example 3 is just a review, and example 4 kind of kick us off into what algebraic models look like. So number 3, I'm going to need a little help on this. So if you get your calculator out, that'd be great. So first thing we're going to do is we're going to use our PEMDAS. We look into parentheses, 18 minus g. We cannot simplify that any. So now we're going to distribute through would be your first step. So is somebody able to tell me what is 28 times 18?
504.
You said 504?
Yeah.
So you get 504 minus 28g. Thank you. Now we combine like terms. We notice that we have two g's here. We have 40g minus 28g. What do we get when we take 40 minus 28?
12.
Good. So you get 12g plus 504. And now what I'm going to do is, since we're solving for g, I'm going to go and flip these around so we have our variable on the left-hand side. So we get 12g plus 504 equals 636. And now we just have a basic two-step equation. Subtract the 504 over. Those cross out. And we're left with 12g equals, what is 636 minus 504? Anybody?
132.
Awesome. 132. Last step. Jason, what's our last step here?
Divide 12.
Good. What do you get? 132 divided by 12.
11.
Good. And that's it. So even though the numbers are bigger, you just still follow the same basic steps. Now we're going to look at an algebraic model. Do I have a volunteer who wants to read this problem? Emma, you want to read?
Sure.
Thank you.
A balloon is released from a height of 5 feet above the ground. Its altitude in feet after t minutes is given by the expression 5 plus 82t. What is the altitude of the balloon after 6 minutes?
Good. So what we're doing is we're taking a word problem and we're turning it into an algebraic expression. Our algebraic expression in this case is given to us. 5 plus 82t. We know that anytime we want to plug in, we use parentheses. So we want to plug in 6. All right, I'm going to bring this up over here. So now in your calculator, what do you get 82 times 6?
492.
Good. And then add 5. You end up getting 497. And then we want to think about altitude. Altitude's being measured. And in this case, is it going to be in seconds, minutes, feet, meters, miles? What's altitude measured in?
Feet.
Awesome. And that's it. So that's what we're going to be looking at today. Miss Karp is going to walk you through some definitions and examples. So I'll send it back over to you, Miss Karp.
Thank you. And one more thing I forgot to add. If you have not already uploaded your note packet to Google Classroom for sections 1.3 to 1.5, do so, because we are filling out these notes for credit. So you guys get credit for filling out these note packets. I think it's pages 11 through 19 in your packet, sections 1.3 through 1.5, what you had your quiz on Friday. All right, so we are going to move right along here into our notes for today. So we're given two definitions. They ask what a verbal model is and what an algebraic model is. So a verbal model is an equation written in words. It's kind of exactly what you would think it means. So we will write equation written in words. So we'll read a problem and we'll kind of explain what our formula will be in words. And then an algebraic model is when we take that verbal model and we make it into a mathematical expression or a mathematical statement. So the verbal model will help us understand it in words, and then we'll bring it into a mathematical statement or an algebraic expression. So let's read our first example they give us. It says a bus travels at an average rate of 55 miles per hour. The distance between Chicago and San Francisco is 2,130 miles. How many hours of driving will it take for the bus to travel from Chicago to San Francisco? So now we're going to reread the problem and highlight what is important. So a bus travels at an average rate of 55 miles per hour. Our average rate of 55 miles per hour there is what we want to remember. Next, they're telling us the distance between Chicago and San Francisco is 2,130 miles. And they want us to figure out how many hours it will take us to drive this distance. So we have our rate, a distance, and time, hours. So if we remember from the last section, we remember that we did the distance formula. We explained the distance formula. Does anyone remember what that distance formula is? It's distance equals something. Distance equals, we just had this on our quiz on Friday too. Someone's got to know it. The other two things are rate and time. So what is it going to be? Distance equals, Haley, do you want to take a guess?
Rate times time.
Yeah. Distance equals rate times time. So that's our verbal model of what we are going to solve for. So we can label, like we did last unit, our distance to be D, our rate to be R, and our time to be T. And now let's just write down what they gave us in the problem. Let's look back again. So the first thing they said is our average rate of 55 miles per hour. So let's write our rate to equal 55 miles per hour. And next, they said our distance is 2,130 miles. (2,130 miles). And they want to know how many hours. So we're solving for our time here. And now we're just going to plug what we know into the equation. So we have our distance to be 2,130. 2,130 equaling our rate, which they gave us to be 55, and our time, which we're solving for, which we labeled t. And now we're just going to solve for t. So like Mr. King likes to do a little flipperoo. We're going to flip our equation. So our 55t is on our left side, equaling 2,130 on our right. To be consistent, so we have our variable on the left, what we're solving for. And Josh, do you want to tell me what step we'll take to solve for t here?
Would you divide or, yeah, would you divide?
Yeah, we're going to divide because the 55 is being multiplied to the t. So the opposite of multiplying is division. Yeah. So we're going to divide both sides by 55. And do you have a calculator? What will 2,130 divided by 55 be?
It says 38 and 8/11.
What's the, does it give you a
It's-
decimal form?
Yeah, 38.72.
Nice. Yeah, good. And we have to make sure we're labeling this. So it's giving us our distance, which was in miles, our rate, which is in miles per hour, and it's asking us for our time. So what should our label be on our time here?
Hours.
Hours.
Yes, good. Questions on that one? So we're first going to read the problem. We're then next going to go through it and highlight what's important. We're going to make a verbal model for what we're trying to solve for, plug everything in, and then solve for our variable. So just adding a few more steps. All right, so we're going to move on to the next example. So this one says, the driving distance between Boston, Massachusetts, and Cleveland, Ohio is about 660 miles. You drive this trip in a total of 12.5 hours. Find your average speed. So let's read through it again. So our driving distance between Boston, Massachusetts, and Cleveland, Ohio is 660 miles. You drive this trip in a total of 12.5 hours. And they want us to find our average speed. So does anyone know what the formula we would use for this problem to be? So first we can write down what we're given. Let's do that. So we have our distance equaling 660 miles. Our time to be 12.5 hours. And they want us to find our average speed. our rate. How do we solve that? What type of formula would we use here?
Would it be 660 equals R times 12.5?
Yeah, good. Because this is our distance equals rate times time formula, our distance formula. Nice. And now we're just solving for a variable, which is R, our rate. And was that Emma? What's the next step we're going to take here to solve for our rate?
You would do 12.5 R equals 660 and then divide.
Yeah. And what are we going to divide by?
12.5.
Yes. Nice. So Emma flipped the equation so that our variable's on the left-hand side, and now she's solving for R. That's great. And what will that give us, Emma? 660 divided by 12.5.
52.8.
Nice. 52.8. And 52.8 what? It's our rate. How fast we're going. So what's the
Miles
label
per
going?
hour.
Yes, good. Awesome. Questions on that one? Being in the car for 12.5 hours sounds like a really long time for me. Has anyone been in the car for that long?
Yeah.
12 hours?
15
Where did
hours.
you go? 15.
I've
Where
been
did you
in
guys?
the 22 because I drove to Disney one time.
Oh, wow.
It was so horrible.
I
I
bet.
drove 36 hours to Houston.
Oh, wow. That's crazy. Well, those both seems like really fun trips. I'm sure it was worth that whole day that you're giving to drive. Definitely painful though. Definitely.
Yeah, it's a lot easier whenever you only have to sit on a plane for 2 hours.
Yeah, definitely. I would prefer to fly. I'm not a fan of
Yeah.
driving long distances. Questions on this one? All right. So we are going to move on to example 2 down below. Now this one's a little different. It's asking us to find a pattern. It asks us, or it gives us, if a jet airplane descends at the rate indicated in the table below, what is its altitude 8 minutes after beginning its descent? So we have an airplane. Let's look at it. Here's our table. We have an airplane. The start of this airplane's descent. So first, when it's first going to start going down, we are at 36,000 feet up in the air before we start descending. So that's our original spot. That's the first spot that we're at. Then after the first minute, after we're going down, I'll draw my little airplane. Let's see how great that looks. Looks like a bug, but I'm not an artist. So after the first minute, now we're at 32,800 feet. Let's find out what this difference is here. How many feet did we descend? Does anyone have a calculator? How many feet did we go down in that first minute? So we're at 36,000 feet, and then the next minute we're at 32,800 feet. What's that difference?
3,200.
Nice. 3,200. So we went down 3,200 feet. We're not going higher. We're not adding height. We're losing height. So it's negative 3,200. What about the next one? So then after 2 minutes, we're at 29,600 feet. So then how much did we go down? How many feet did we descend?
3,200.
Nice, yeah. So 3,200 also. And you're going to see that's the same for going from 2 to 3 minutes, from 29,600 to 26,400. That's another minus 3,200. And the same thing here. Minus 3,200. So we are going down 3,200 feet every minute. We're descending 3,200 feet per minute. So let's think about this verbally. So they're giving us our altitude, time, and our distance. So we want to figure out, they're asking us, what is the altitude 8 minutes after beginning its descent? So we want to find what our altitude is. And our altitude will be our starting height, what we started at, minus what we're descending every minute. So how much we're going to go down every minute. So that's our rate of descent, right? Multiplied by our time. So what our rate is multiplied by how many minutes we're going in. So we are trying to figure out what our altitude is here. So we'll copy that down. Our starting height is our 36,000 feet, what we started at before we started descending. So our original, so a times 0. Our 0 is like an O, like your original height. So that's 36,000. And then we're minusing our rate of descent. So the rate is our 32,000. So this is like adding. You're going to add whatever you're changing. You're going to add whatever your rate is that it's changing. Our rate here is negative 32,000 or 3,200. So 3,200. And you have to make sure you bring that negative with it because we're going down. And then our time. So questions on this one. So to find our altitude, we're going to take our original spot in the air and we are going to add how much we're changing. And here we're going down. So that's why we have this negative here. So then to write this a little simplified, we have 36,000 minus 3,200 T. Questions on that? So that's going to be the equation that helps us find what they're asking us for. So they're asking us, what is the altitude 8 minutes after beginning its descent? So instead of subtracting 3,200 and doing like 5, 6, 7, 8, doing it this long way, we made this formula for us to use. So our time is 8. So we're going to plug our time of 8 in for our T right here. So our altitude equals 36,000 minus 3,200 and parentheses because we're plugging in our time, which is 8. So does anyone have a calculator? Does anyone know what 3,200 times 8 is? And you don't have to rewrite it a bunch of times if you don't want to. I'm just doing it to have it laid out for you guys so it's easier to understand and see. If you guys don't want to write altitude every time, it's fine. So what's 3,200 times 8?
25,600.
Nice. And now what's 36,000 minus 25,600?
10,400.
Nice, good. And so what is this 10,400? It's our altitude. So 10,400 what?
Feet.
Feet, right. That's what we're working with. And that's it. And that's our altitude after 8 minutes. So after 8 minutes, we are at an altitude of 10,400 feet. Questions?
No.
So Emma, if you flew to Florida, you could be up in the, instead of driving, if your plane was descending 3,200 feet per minute, after 8 minutes, you'd be 10,400 feet in the air instead of driving for 22 hours. Questions? All right, let's flip to the next page in your packet. So example number 3, they say draw a diagram. It's home improvement problem. So you want to paint 5 1-foot wide vertical stripes on a wall. There is to be an equal amount of space between the ends of the wall and the stripes and between each pair of stripes. The wall is 14 feet long. How far apart should the stripes be? So that's our problem. And now we want to go through, reread this and highlight what's important. And we're going to draw a diagram so that it's easier for us to see. So you want to paint 5 1-foot wide vertical stripes on a wall. So we have a wall. This is my wall. And we want to paint 5 1-foot wide vertical stripes on this wall. So we have 5 stripes to go on here. But there has to be an equal amount of space between the ends of the wall and the stripes and between each pair of stripes. So there has to be equal length between each of these stripes and the ends of the wall. So I'm going to do my best to draw my 5 stripes. Oh my goodness. So we have 1 stripe. Here's another one. 3. 4. And 5. So not perfect, but it's the best of my ability. So we have an equal length. So first, these stripes are 1 foot wide. So each of these are 1 foot. They're taking up 1 foot. So we're going to label under each of them that it's taking up 1 foot. So that's already 5 feet of this wall. And next, they're saying there is to be an equal amount of space between the ends of the wall, which are here, and the stripes between each pair of the stripes. So each of those lengths there are the same. So but we don't know that length right now. So let's make that X. So I'm going to do this up top. Actually, let's do it down here. So that length is X. That length is X. Each of those lengths are X. And I'm just drawing the Mrs. Kane's favorite curly Q bracket. Mine aren't as cool as hers. Next, they're saying the wall is 14 feet long. So now we know the length of this whole wall. I'll do it up here. The length of this whole wall is 14 feet. And we want to figure out how far apart the stripes will be. So we want to figure out this X length, how far apart the stripes are and how far they are away from the wall. So we have our length of our wall to be 14 feet. So we know all of these lengths added up are going to be 14. So we have 14 equaling, let's look at the stripes. So each of the stripes are 1 foot long. So we have 1, 2, 3, 4, 5. So we know that the stripes take up 5 feet of this 14 feet. And the rest of this wall are the spaces between the stripes and the wall that we're trying to figure out, our X here. And we have 1, 2, 3, 4, 5, 6 X's. So our wall is 14 feet long, which is made up of our 5 stripes and the 6 spaces between them. Questions so far on the diagram or making this formula equation? So they want us to figure out how far apart the stripes should be, and that's the X that we made, the distance between the stripes. So now we're going to solve for X. Haley, could you tell me what our first step here to solve for X would be with our equation over here?
Subtract 5 to both sides.
Nice. I'm gonna... Oops. A little frozen here. Nice. So she is subtracting 5 from both sides. I'm just erasing that. That's not division. That was me trying to explain the parts of it. So nice. So we have 14 minus 5. That gives us 9. Equaling 6x. We can flip it so that we have our variable on the left. So then we have 6x equals 9. And what's our last step, Haley?
Divide by 6.
Nice. Yeah, to get our x alone. And that will give us 9 over 6. Can we simplify that? Can we simplify that fraction?
Yeah.
And what will it simplify to?
3 over 2.
Nice. Thanks. Yeah, so now we have our x is 3 over 2. So what is our x? Our x was the space between the stripes and the wall. That's what we wanted to solve for. We can't just say x equals 3 over 2. We have to label that. So what is our label on the 3 over 2? How far apart the stripes are between them and to the wall? What should that label be? 3/2 what?
Feet.
Yeah, it's 3/2 feet. So they are 3 over 2 feet, 3/2 feet apart, the stripes. Questions on that one? So it's very important to draw the diagram. Take the time to draw the diagram so you can see what's going on. Figure out what you have and what you need to solve for. Your stripes probably look a lot prettier than mine. All right, so we are going to skip extra example 3A and we are going to go down to example 4. So example 4 says, down the bottom here, it says you borrow $195 from your aunt. Your aunt is not charging you any interest. I should say, but, there's just a T there, but you want to repay her as soon as possible. You can afford to pay her $15 per week. Use the problem-solving plan to find how long it will take you to repay your aunt. All right, so let's reread this. You borrow $195 from your aunt. So we're borrowing $195. She's not charging you any interest, but you want to repay her as soon as possible. Very nice of them. You can afford to pay her $15 per week. Okay, so we owe the aunt $195. And we can pay her $15 per week. So that's equaling and let's label our weeks W. And she's not charging us any interest, so we're not subtracting any amount from that $15 we're giving her every week. So that's the only thing that we'll have on that right-hand side, because we want to figure out how many weeks it will take us to get to $195. So how many weeks until we add up $195? So now we're just going to solve for W. So we can do a little switcheroo. So we have our variable on the left. Questions on this part? If she was charging us interest, then we'd have to subtract from this side what we're giving her. Then we'd have to add something there. So now to solve for W, what's left we have to do?
Divide by 15.
Nice. We're going to divide by 15 on both sides. And can someone tell me what 195 divided by 15 is?
13.
13. Nice. And we can't just write 13. What is our 13? What does our
Weeks.
13 mean? Yeah, 13 weeks. So it will take us 13 weeks to reach $195 with giving her $15 every week. Questions on that one?